So in this video we are going to be looking at straight line graphs slash linear equations. Okay, linear equations. Now remember, linear equations have no powers. And any linear equation, an equation with y and x that has no powers, will produce a straight line graph. So here's two examples of linear equations: y equals 3x minus 2. That has no powers. And 2y plus 8x equals 5. That's also a linear equation, which will produce a straight line graph. So in order to plot this straight line graph, you might do a table of values. So you should pause the video now and do the table of values, complete the table of values on the sheet for both of the graphs. Okay? One's on one side, one's on the other. When you do that table of values, well, if x is minus 2 for the first one, minus 2 times 3 is minus 6, take away 2 is minus 8, minus 1 times 3 is minus 3, take away 2 is minus 5, etc. Okay? Notice how they go up in threes. We could draw a graph. I've drawn the graph for you on your sheet. You plot the points, so I would plot the point minus 2, minus 8, minus 1, minus 5, 0, minus 2, etc., and draw the line through them. Now they line up in a straight line. Okay, in order to do this equation, the first thing you might do is rearrange it. So rearrange this equation to make y the subject. So you might want to pause the video and try rearrange to make y the subject. I will go through this at some point during the video, but for now, if you do rearrange this, if you pause the video and tried it, then you will get y is equal to minus 4x plus 2.5. This makes it easier to do the table of values. So if I put minus 2 into the equation, minus 2 times minus 4 is 8, plus 2.5 is 10.5. Minus 1 times minus 4 is 4, plus 2.5 is 6.5, etc. Okay, plotting these points, I have done this for you on the graph, but you end up with something like that. Something like that. Okay. Now, the key thing that I really want you to get out of this video is the relationship between the equation and the graph that we've produced. So all points on the line, all points on the straight line, can be generated. They come from the equation. They're generated by the equation. So all points on the line are generated by the equation. I really want that clear, the relationship between the equation and the straight line graph. Okay, now let's look at some questions related to straight line graphs, which you should all know from shell and low remove. Okay, so an example of a question. Does the point a quarter, comma, minus 5 over 4 lie on the line? Lie on the line y equals 3x minus 2. So what is this asking? Well, on the right is the point on the line. But if we're looking at the equation, it's if I put x as a quarter into the equation, do I get the answer y is minus 5 over 4? So, well, we know y is 3x minus 2, but x is a quarter, so if I substitute that in, I get 3 times a quarter minus 2. You should pause the video now and really just complete this sum. So it's 3 times a quarter, which is 3 quarters, and minus 2 is minus 8 quarters. 3 quarters minus 8 quarters is minus 5 quarters, minus 5 over 4. So, yes, it does lie on the line, because points on the line are generated by the equation, and the equation generates this point. Okay, that's the point there, a quarter, minus 5 over 4. If you turn the page, you could probably try this question now. Does the point minus 312 lie on the line 2y plus 8x equals 5? Now you could do this in two ways. You should really pause the video and try this yourself, but you could do it in two ways. You could see if when you put x and y into the left-hand side of that equation I've written, do you get an answer of 5? Or you could use the rearranged equation here to do it. So if I do put y as 12 and x is minus 3 in, well, what is that? That's 24, take away 24. And that gives an answer of 0. but I wanted the answer to be 5, and this isn't 5. So it doesn't lie on the line. So no, it's not on the line. Okay? The equation doesn't generate the point minus 312, so it can't lie on the line. And in fact the point is there, which is just below the line, it's not on the line. Okay, another question then. So we're going to look at gradients. So what is the gradient of the line y equals 3x minus 2? What is the gradient of that line? Well, there are two ways. We can either look at the drawing, the plot, or we can look at the equation. If we look at the plot, we know that gradient is rise over run. Gradient is just a number. It's only a number, and it's a measure of steepness. And we have it as the rise over the run. So we can draw a triangle where the height of that triangle, it has to be right angled, is the rise, and the bottom is the run there. Okay, we know what the rise is because it goes from the height, it goes from 1 to 4, so the rise is 3. The run goes from 1 to 2, so the run is just 1. So the gradient is equal to the rise over run, which is equal to 3 divided by 1, which is equal to 3. So the gradient is 3. But if you notice, in the equation, 3 appears here. And we know from lower remove that when we have an equation of the form y equals mx plus c, m is the gradient. So that's why the gradient is 3. There are two ways to do that question. Okay. Looking at this question then, what is the gradient of the line 2y plus 8x equals 5? Now you should really pause this video and answer this question. Okay, so as I said, there are two ways. You can do the gradient is equal to rise over run again. Drawing the triangle. It doesn't matter how big I draw the triangle. Okay. Now in this triangle, you can see that the run is 2, and the rise, well, it goes from 2.5 to 10.5. So that means the rise is 8. But because it goes down, it's a rise of minus 8, really. So it's a rise of minus 8 and a run of 2. Okay, so the gradient is minus 4. Now remember, negative gradients slope downwards and positive gradients slope upwards. So this minus 4, well, you can see it appears in this equation, and now this equation is of the form y equals mx plus c. We wouldn't have known that if we were just looking at this equation here. If we were looking at that equation, 2y plus 8x equals 5, we wouldn't know the gradient. We would have to rearrange it into the form. Okay, and to rearrange it, if you haven't done this already, you should pause the video and try this. To rearrange it, we're making y the subject. So we could take away 8x from both sides, and then we could divide through by 2. Okay. So really, to find the gradient using the equation, you need that of the form y equals mx plus c. Okay. Now, we're moving on. We're going to look at the y-intercept. The y-intercept. The y-intercept is where it crosses the y-axis, which is that point there, which I've just circled. Okay? It's that point there. So what is the value of the y-intercept? Well, you can just read it off. And actually, for this equation, the y-intercept is equal to minus 2. Now notice how minus 2 also appears in the equation. So the graph and the equation are related. Now, if the equation is of the form y equals mx plus c, then c is the y-intercept. In our case, c is minus 2, so the y-intercept is minus 2. The graph and the equation are related. Okay, so what is the y-intercept for 2y plus 8x equals 5? Now it's not 5. It's not 5 because it's not of the right form. The y-intercept is when it's of the form y equals mx plus c. So the y-intercept is 2.5. Now you could also circle that point there, and that point on the y-axis is 2.5. Okay? Next. This is just sort of a revision. What is the equation of the straight line drawn? Now, we know what the equation of the straight line drawn is, but how could we do it if we didn't know the equation? Well, we need to find the gradient, which is rise over run, and that's equal to 3. because we did that earlier. We need to know the y-intercept, and in this case it's -2. And when I know that, I can just write down the answer, because I know m and c, so it's y equals 3x minus 2. An equation parallel to this would have the same m, but a different y-intercept. So y equals 3x plus 10 would have the same gradient, it would be parallel, but a different intercept. Now you might want to pause the video is about to end here, but you might want to write down the steps. How would you find the equation of a straight line if it was drawn? And I think there's, on the first page of your notes, you can fill out that little section. How would you find the equation of the straight line from the graph? Okay, that's pretty much it for straight lines. I hope this was helpful revision. It shouldn't be anything new. See you on Monday.